Quality control rules. A multi-rule approach is recommended when evaluating quality control results for quantitative tests. 1. To minimize false rejection. 2. Maximizing error detection. 3. These rules are useful tools for detecting, evaluating, and determining appropriate action for random and systematic errors. For the 1-3S and 2-2S rules are the most commonly used quality control rejection rules. Rule 1-3S. 1 control value is more than 3 SD above or below the mean. Type of error: random. Corrective action: 1. Reject the run. 2. Investigate and perform corrective action. 3. Document corrective action. 4. Repeat the run. Rule 2-2S. 2 consecutive control values are more than 2 SD above or below the mean. Type of error: systematic error. Corrective action: 1. Reject the run. 2. Investigate and perform corrective action. 3. Document corrective action. 4. Repeat the run. Rule R4s. The difference between the highest and lowest control result of a run is more than 4 SD apart. Type of error: random error. Corrective action: 1. Reject the run. 2. Investigate and perform corrective action. 3. Document corrective action. 4. Repeat the run. Rule 4-1S. For consecutive control values are more than 1 SD from the mean on the same side of the mean. Type of error: systematic error. Corrective action: 1. Reject the run. 2. Investigate and perform corrective action. 3. Document corrective action. 4. Repeat the run. Rule 10x. 10 consecutive control values fall on the same side of the mean. Can either be 10 consecutive of 1 control material or 5 consecutive of 2 control material. Type of error: systematic error. Corrective action: 1. Reject the run. 2. This control rule is not often chosen by laboratories as a rejection criterion. Reviewing QC. Daily QC review. QC data should be evaluated daily by the testing personnel or supervisory staff to detect trends, shifts, random variations, or other issues. Monthly review. QC data must be reviewed by the laboratory director, technical consultant, or other designated technical supervisor. QC review performed by the laboratory director or designee should include all of the following. 1A review of statistical data for quantitative procedures. 2A review of QC charts. 3. Checking for shifts or trends in the control values for quantitative procedures. 4. Verification of appropriate corrective action when data outside of acceptable QC ranges. 5. Recommendations and documentation of the implementation of remedial action. 6. Documentation of monthly review. Reviewing QC. Reviewing QC results and implementing corrective action. The appropriate corrective action in each scenario would be to review the Levy-Jennings charts to determine the type of error, consider the potential causes of the error type, and do corrective action. 1. Determine the type of error. Is it random or systematic? Rules assessing imprecision, such as 1-3S and R4's failures, are usually associated with random error. B. Rules assessing consecutive control observations, such as 2-2S, 4-1S, and 10X, are usually associated with the systematic error. 2. Consider the potential causes of the error identified. Have any recent changes occurred in calibration, reagents, or maintenance? Reviewing QC. Factors that contribute to random error include 1. Bubbles, clots, or clogs in reagents or reagent lines. 2. Instrument instability. 3. Temperature variations. 4. Operator variability, such as variation in pipetting or inattention to specific testing detail. 5. Incomplete mixing or reconstitution of the quality control vial. 6. Influence of improper environmental storage or preparation for the use of quality control material. Reviewing QC. Factors that contribute to systematic error include 1. Change in reagent lot. 2. Change in calibration. 3. Incorrect calibrator values assigned. 4. Improperly prepared or deteriorating reagents. 5. Pipetter maintenance error, not adjusted correctly or misaligned. 6. Deterioration of a photometric light source. Reviewing QC. Is the QC failure specific to one analyte or many analytes on a multi-test instrument? Failure of multiple analytes requires the determination of common factors for the affected tests. Examples include 1. Detection system. 2. Filter or optical system. 3. Pipetter or sampling system. 4. Diluent. Failure of a single analyte requires attention to the specific affected test system. Examples include 1. Deterioration of reagent, diluent, sample. 2. Calibration factors or deterioration of calibration. 3. Specific test steps or materials, dilution, extraction, electrode. After identification of the problem, perform and document the appropriate corrective action. Evaluate the patient results in the previously failed run for clinical significance. When appropriate, repeat the patient testing. Document the corrective action taken. QC testing protocol. Acceptable, then proceed with patient testing and result reporting. Unacceptable, then repeat QC testing with fresh aliquot of control materials. Acceptable, then proceed with patient testing and result reporting. Unacceptable, then inspect QC charts to determine the type of error. Then take appropriate action, example, instrument maintenance, recalibration. Then repeat QC testing. If unacceptable, then call technical service. If acceptable, then proceed with patient testing. You need to evaluate patient results that have been reported since the last successful QC testing event. Then issue corrected reports if needed. And document corrective actions. Adjusting the mean. 1. When quality control analyses are consistently outside the acceptable range, one possible corrective action step is to adjust the target mean. 2. This is an action that should not be the first step nor one that should be done without careful consideration and guidance from appropriate personnel, such as the technical consultant or laboratory director. 3. A review of peer data generated from the interlaboratory quality control programs provides valuable data before making a mean adjustment. For these programs, allow the laboratory to compare the current data with laboratories utilizing the same lot of quality control material and instrumentation. 5. A comparison of the group's mean may justify making the mean adjustment to provide an appropriate, acceptable range which will lead to quality control results that are acceptable for the individual laboratory as aligned with peer data. 6. An additional source of data for review and comparison includes recent proficiency testing performance. 7. This data may be used in conjunction with information from the recent performance of the assay, recent calibrations, maintenance, etc. Before adjusting a mean, consider the following in your QC statistics. Identify the problem if bias. Bias means results consistently above or below the reference mean value. Example, peer group means in proficiency testing or interlaboratory QC programs. Identify the possible cause. 1. A consistent significant bias could signal calibration error. 2. Reconstitution error of control material. What are the suggested preliminary actions? Analyze an assayed control or a PT specimen from a previously graded survey. For results near the mean, re-evaluate QC ranges. Results exhibiting the same bias as the QC recalibrate. If the problem is excessive scatter. Means data points are scattered in all directions above and below the mean. Demonstrates poor precision or reproducibility. The possible causes are 1. Operator variability, for example, inconsistent pipetting. 2. Specific detail omission or improper performance. What are the suggested preliminary actions? Possible sources, components of the test system, such as sample probes, reagents, and reaction cuvettes. Operator error, such as data entry error, miscalculations, and pipetting technique.
Shift means several data points, example, 6 or more, in a row fall on one side of the mean, exhibiting a shift from previous control performance. Possible causes. 1. Recent recalibration. 2. New lot of reagents implemented. 3. Change in instrument performance. Analyze. Suggested preliminary actions. Check reagents and replace if necessary. Analyze an assayed control or a PT specimen from a previously graded survey. If results are outside the manufacturer's range or peer group results, recalibrate. In case of trend, data points demonstrate a gradual move away from the mean in a specific direction over an extended period, e.g., 7 consecutive values consistently moving in one direction away from the mean. Possible causes. 1. Outdated or deteriorated reagents. 2. Shift in calibration. Suggested preliminary actions. Check reagents and replace if necessary. Analyze an assayed control or a PT specimen from a previously graded survey. If results are outside the manufacturer's range or peer group results, recalibrate. A mean adjustment may be warranted if QC demonstrates bias, a shift, or a trend, and all sources of possible error have been investigated, and no correlation can be determined between the error and a possible cause. All mean adjustments will require documentation, and subsequent quality control runs will need to be monitored. Delta checks. A delta check is a quality control tool for comparison of current laboratory test results to previous results obtained on test samples from the same patient. The comparison often includes a specific time period, e.g., 1 month. Delta check analyses can be programmed into the Laboratory Information System, LIS, to detect an error. For example, a delta check for a PSA value would compare a patient's current PSA of 13.5 nanograms per milliliter to their last value, obtained perhaps 6 months ago, which was 2.5 nanograms per milliliter. This significant change could indicate pathology for the patient or an issue with the testing or test sample. The Laboratory Information System, LIS, would alert the instrument operator to this significant change. Laboratory protocol would then be followed as to the proper steps to be taken to determine if the quality of the evaluation was in question or was the change a result of a change in the patient's status. Delta checks are incorporated to assist in error detection. Examples of errors possibly detected by delta checks include 1. Sample interference from hemolysis, icterus, lipemia, and contamination with 4 fluid. 2. Specimen misidentification. 3. Manual transcription error. Delta checks. 1. The errors mentioned above are quality issues that may not be detected by testing QC materials. 2. For most tests, it is unlikely that consecutive results obtained on one patient will vary significantly unless a substantial change has occurred with the patient's medical status. 3. If multiple delta checks fail on several tests performed on a single patient, there is a strong possibility that the specimen or patient, at the time of specimen collection, was misidentified. 4. Delta checks are not appropriate or useful for every analyte. 5. Analytes most appropriate for delta check analysis are stable analytes with little day-to-day variation and are frequently measured. MCQs. Question 1. the supervisor has reviewed the monthly QC for all analytes. For calcium, the QC results for the last 7 days of the month were below the mean. Various operators tested the quality control on these 7 days. Corrective action is initiated. Which of the following is appropriate as a first step? Please select the single best answer. 1. Adjustment of the mean to the value of the last 4 points of the previous month. 2. Review of peer data from interlaboratory quality control programs. 3. Start a new lot of quality control. 4. Make a change of operators and compare results. The correct answer is 2. Review of peer data from interlaboratory quality control programs. Question 2. The hematology department utilizes mean corpuscular volume, MCV, as a delta check. A patient who was in the hospital for 4 days had the MCV delta check alert on day 4. On day 1 of his admission, the MCV was 93 FL, and on day 4, the MCV was 100 FL. Which of the following is the most probable reason for this alert? Please select the single best answer. 1. Quality control out of range. 2. Calibration out of date. 3. Reagent out of date. 4. Sample misidentification. The correct answer is 4. Sample misidentification. Question 3. Which of the following Westgard multi-rules will assess random error? Please select the single best answer. 1-3S, 2-2S, 4-1S, 10X. The correct answer is 1. The 13th rule will detect a single control value that exceeds 3 standard deviations from the mean, which would be a random error. All the other multi-rules listed look at consecutive data points, which is consistent with systematic error. Question 4. Which of the following factors may be attributed to random error? Please select the single best answer. 1. Calibration change. 2. Reagent lot change. 3. Deterioration of the photometric lamp. 4. Personnel variability. The correct answer is 4. Variability in personnel technique would cause a random error. A change in calibration, reagent lot, or diminishing photometry bulb will result in across-the-board changes on repeated controls, indicating a systematic error. Question 5. The laboratory performs a single method for analyzing genetic testing for tumor markers for rare cancer in children. No commercial proficiency or assay materials are available for this testing. Which of the following may represent the most appropriate method to assess accuracy? Please select the single best answer. 1. Use an alternate in-house method for reanalysis. 2. Previously assayed materials from a national reference laboratory. 3. Internal split sample analysis with alternate testing personnel. 4. Peer comparison programs. The correct answer is 2. Previously assayed materials from a national reference laboratory. Question 6. A new laboratory is ordering proficiency testing, PT. Which of the following reflects a compliant process? Please select the single best answer. 1 point for all regulated analytes must be ordered from a single PT provider. 2. Only 50% of the regulated analytes must have PT performed for each event. 3. The laboratory may perform PT utilizing a clinical validation by review of calibration records. 4. The newly enrolled PT program must be used for 1 year without changing to an alternate provider. The correct answer is 4. The newly enrolled PT program must be used for 1 year without changing to an alternate provider. Question 7. A new laboratory in a small physician's office evaluates chemistry and hematology samples. The laboratory has registered for proficiency testing, PT, and has received the first set of hematology samples. The technical consultant is on contract and does not perform testing. Which of the following statements reflects the proper way to evaluate these samples? Please select the single best answer. 1. The technical consultant should perform the PT. 2. Testing personnel should perform the PT. 3. The laboratory director is the only person who can perform PT. 4. PT is always tested by the same person. The correct answer is 2. Testing personnel should perform the PT. Thank you for watching. Don't forget to like, share, subscribe. See you next video.